Like I mentioned before, after all this while, we are going to formally introduce you the concept of IP address, MAC address, and port number. Again, no details, not much details at least, which is what the rest of the training is all about. But just to introduce you the concepts. After this lesson, you will see a lot more details very soon. So we are trying to understand port number, IP address, and MAC address. Those are the three numbers we find in the context of networking. There are other numbers, but these are the numbers we are going to focus at least for the time being. Now, let's try to understand a little more on the namespaces which these numbers are allocated to. Just like in the case of street, the pin code, etc. What is the country here? What is the street here? That's the kind of thing we are going to discuss first. So the ultimate purpose of computer networking is transfer data between different computers or different computer programs, potentially running in different computers. They could be kilometers apart. They could be in different continents. They could be even in different hemispheres of the earth. In certain cases, it may be in outer space. Doesn't matter where the program is running, the client and server so they can be pretty much anywhere in the world. So the ultimate purpose of computer networking is to transfer data, like we saw, between client and server, two different computer programs. Now, let's draw a diagram of a company. So this is a particular company, company A we are drawing here. This is company B, and this is a home, and this is a public library. Company A, company B, and home. Basically, different places or different isolated regions where different computers are present. So there is a computer here. There is another computer here in company A. Company B has some more computers inside company B. These computers can be anything. It can be phone, laptops, desktops, anything you can think of. Same with the home. There are a couple of people. So they are using a couple of laptops, desktops, phone, whatnot. Probably there are a couple of devices as well we can call computers. Same with the library. Now, these computers, so these are computers, has different programs running inside. There are so many programs, just like in this laptop right now, so many programs running inside. Everywhere, so many different programs. Now, company A is very private. Company A is very secretive, and they don't want any of their data or computers connected to outside world. So very private company. So they don't have any connection to the outside world whatsoever. Company B is connected to certain homes and library. Company B is a little more open. So there are computers connected. So in this case, in terms of computing, let me draw the network perimeter. So this is the network perimeter which I am drawing. So this blue box which I have drawn right now is a network perimeter for company B, home, and the public library. Now, company A is not connected anywhere. Company B has connection outside, but company A is very private. So let me draw the network perimeter for company A. Company A's network perimeter is this because it's completely private. No one else accesses it. So there are a couple of different entities here. One is different computers in company A. These are different computers. Now there are different programs running inside computers. So there are so many different clients and servers like we developed. So they can communicate to each other in company A. Internal communication has to be done. Here it's more open. Same problem. So many computers are here. Here also there are so many computers. So I'm going to number these computers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So total 13 computers are there which can communicate to each other in this network perimeter, this blue network perimeter. In this case, there is only 1 and 2. Now here we can repeat these computer names because there is no connection between these two guys. That's why I repeated these numbers 1 and 2. Now, I'm going to number these programs as well. This is P1, this is P2, this is P3, etc. 4, 5, 6, 7, 8, 9. So there are different programs. In this case, what I can do is, instead of 6789, I can repeat the number because I have this 2 right here. So what I'm going to do is, I'm going to name it 1, 2, 3. So if I want to address this particular program right here, I can address it like second computer, third program, like so. Within this company, it will be a unique number. Same with here. If you number the programs inside a computer, you can put numbers and you can repeat the numbers in different computers because the computer themselves has numbers. And the numbers of the computer can be repeated in a different network perimeter as well. As you can see here, the company A is highly isolated. This is exactly the purpose of IP address. IP address is the number of the computer or a system or a NIC card, to be very rigorously talking. But for the time being, we assume that it is a number of a computer. Probably 99.99% of the cases, IP address is always pointing to a specific computer. We'll discuss some of the exceptions, some of the important exceptions we will discuss. But for the time being, it is the number of a computer sitting in a network perimeter. So the number can be repeated in a different network perimeter. For example, these are 2 different networks. They can have same IP address for 2 different systems. It's like the house number again. You can have same house number for different streets. You can have same PIN code for different countries. Like that, you can have same IP address in different network pointing to different computers. So IP address is the number or the address of a computer or a system or a server. Now, what about port? Port is the number of the program inside a computer. So port is equal to this second number right here. Again, it can be repeated between different computers. We will see that. And it cannot be repeated in the same computer as well. We'll see that as well. Also, in the same network perimeter, an IP address cannot be repeated. For example, if you have same house number for 2 different houses in a particular street, there will be ambiguity. The postman will be confused, visitors will be confused, everyone will be confused. Someone will make problem for that. Similar to that, here also, the IP address is the number of a system, a computer, within a network perimeter. In fact, the network perimeter is defined by the IP number space or the IP address space. We'll see how IP address is designed when we talk about the IP protocol, but the idea is this. Now, what is MAC address? So MAC address is very similar to IP address in terms of this discussion is concerned, but MAC address is more permanent number of a computer. You can think of it like a name of a person. So for example, if a person is going to a different place altogether, for example, Bob moved to Queensland from Melbourne. Now Alice has to send the letter to Bob. But now his house number has changed. His IP address has changed. IP address can change, but Bob has not changed his name. His name is exactly the same. Again, the house number is kind of the number of the Bob itself. Not exactly Bob, but that is the house number in which Bob stays. But that has changed. The IP address changes. But name doesn't change. Bob is keeping his name. He don't have to change his name because he is moving from one city to another. The MAC address is similar to that. MAC address is a very device specific. It's like a DNA for the device, the physical NIC card. In fact, it is a hard-coded number inside the firmware of the NIC card. If you're into network device drivers, you will know that it is a number you can read from the firmware or from the device. It is part of the device configuration. And for a particular hardware, particular NIC card, the physical NIC card, the MAC address is permanent. It doesn't change. There are certain scenarios in which we can change MAC address by changing the virtual device MAC address, etc. But that's not the point of this discussion. MAC address from this discussion perspective is permanent and part of the DNA of the device itself. A device which is connected to the computer. On the other hand, IP address changes all the time. IP address doesn't have any permanency, just like the house number. When the person moves, the house number changes. So does the IP address. For example, your laptop is having an IP address right now. When you connect to a different network, it has a different IP address. For example, there is an employee right here using this computer. This employee is using his laptop right here. For some reason, this laptop or this employee has to move to this company A. Now, his MAC address remains the same, but his IP address will change and he will get IP address from this network perimeter, but his MAC address remains the same. Now, if he wants a different MAC address, what he has to do? He need to buy a new laptop, or at least he need to change the NIC card of the laptop. We have seen the NIC card, which is a network interface card. That's where your MAC address is there. There are other uses for MAC address when it comes to subnetting. We will discuss that, but for the time being, port is all about the program within a computer, number of the program, the address of the program. That is port is all about. IP address is the address of the computer itself, and it can change based on the location of the computer. Even at same location, you can have different IP addresses. We'll see how the IP address is assigned using DHCP protocol. But IP address is very dynamic. Every time you can get a different IP address. The MAC address, on the other hand, is very permanent and it is very device specific. It is like the DNA of a particular NIC card which is connected to a computer. From this discussion perspective, I assume that there is one computer and there is only one NIC card connected to a computer, physical or virtual. That's a simple scenario, or the simplest scenario which we are discussing here. And the computer has multiple programs running inside. So this is the computer, one NIC card and multiple programs. That's the fundamental assumption we are taking in this discussion. This is not always the case. In fact, it is never the case, more than often, but it serves the purpose here. So what is the summary of this discussion? Port number is the number of the program and IP address is the number or the address of a computer, and MAC address is a permanent number of the network interface card, which is very permanent. IP addresses changes for a system, while MAC address doesn't change. So to conclude, we have seen the basics of three numbers: MAC address, IP address, and port. Again, not in detail, but we need to get into the details. In fact, that is what this training is all about. At least rest of the training. We'll be playing around with these numbers, MAC address, IP address, and port, and getting into different levels of details.